Before we start getting into the course content, I'd like to talk about what it is about chemistry that I love. And I've got a little document here that I'll go ahead and share with you. So what does this wood and this donut, what molecule do these guys have in common? And the answer to that is glucose, C6H12O6. This thing is glucose. This thing is glucose. Now, there are obviously other things in there, like there's some fat and sugar inside the donut. There's some protein and whatnot in the donut, and protein in the wood called ligand. But for the most part, what we're talking about is glucose molecules. The glucose molecules are connected to each other in a chain. And so that chain would be called a polymer. So we probably thought about or heard the word polymer and thought plastics, but nature came up with polymers first. And so the polymer of glucose has a couple of forms, 3 forms specifically, but we're just going to talk about 2 of them. So the first one is starch. So this is what our donut is made out of. And then the second one is cellulose. This is what the tree is mostly made out of. So what we have here, these are anywhere there's an end or these corners inside of this hexagon, that's a carbon. So there's 1, 2, 3, 4, 5, plus the 6th carbon. And these ends of these are hydrogens. So there should be an H written there, there, and there. And there's actually another one there. And then this is a glucose molecule connected to a glucose molecule, connected to a glucose molecule. So starch, we think about starch, we probably think about like mashed potatoes or potato chips or rice or bread. And this is something we obviously can consume and get energy from because we have a piece of protein called an enzyme. And the enzyme is called amylose, and that or amylase, and that comes in and can break this bond here because we use the glucose molecule on a cellular level to power all of our cells. It manages something called, it provides energy for something called adenosine diphosphate to turn it back into adenosine triphosphate or ATP, which is the thing that powers muscles. And so this guy right here is useful to us. This chain is not useful. So if we can't break these glucose molecules apart, we can't use this starch. But luckily, our body knows how to build the enzyme, which is the key to unlocking these glucose molecules from each other. So you have this enzyme in your mouth, which is to say, if you were to take a potato chip and chew on it, but keep chewing on it for like 5 minutes, the potato chip will eventually taste sweet because the amylase in your mouth will break these glucose molecules apart, and instead of having starch, which has not sweet flavor, you'll end up with these glucose molecules, and this will be sweet. Okay, great. So individual glucose molecules coming off of starch compounds, this is something we can eat. This is the tree. Well, we can't eat the tree, and the reason is because the connection between the glucose molecules is different. So if we were in class, I just ask everybody, and so nobody's here to answer my questions. So the difference is this glucose molecule is inverted from this glucose molecule. So in the cellulose polymer, every other glucose molecule is, for all practical purposes, upside down. We do not have the key to break this down. If we did have the key, it would be amazing. We would never starve because if you got hungry, you could just drop down on all 4s and start mowing away the grass. You wouldn't need a weed whacker anymore. You could just go munch. You could maybe bring out a little bit of Italian dressing and spray it on there, give it a little spritz and eat away. So we can't do that because of this inverted glucose molecule. Because this guy is upside down, we don't have the ability to break this bond between these molecules. Obviously, herbivores like goats and cows and deer and whatnot can break that apart. They don't actually do the breaking apart so much as they have bacteria within their guts that do the breaking apart for them. If we could incorporate those bacteria into our guts, then we could eat grass and not starve. So I just think it's amazing to look outside, and when I see a tree, what I'm thinking to myself is that's an awful lot of sugar. And that's what it is. It's mostly sugar. If you were a cow, you look out and see a field of grass and don't think field of grass, don't think cellulose, you think food. You think, hey, that's going to sustain me. That's basically a donut for me. Okay, so this is one thing about chemistry that I just find fascinating. Something else, a couple more things here. So hydrogen gas is very flammable. If you don't know that, you will know that before finishing up this class. It's the first element, and it always forms a pair with itself as well as oxygen. So this is a hydrogen molecule, two hydrogens connected to each other, and the air that you breathe is two oxygens connected to each other, and we just call it oxygen gas. And if I put those two things together, I will make water. So hydrogen is flammable. Oxygen is the other reactant you need for a combustion reaction. You put them together and you make the thing that puts out fire. So flammable, thing that makes fire, put those together, I make the thing that puts the fire out. So I always thought that was interesting. And another example would be, this is the symbol for sodium. So sodium is a metal, and it's a metal that's very, very reactive. If you were to throw some of it in water, you would find yourself witnessing a small explosion. If you were to put this into your mouth, your head would explode. Your whole mouth, the saliva in your mouth would cause the sodium to explode, or a subsequent reaction. And chlorine is a gas on the periodic table, element number 17, on the right-hand side next to argon. And if you were to breathe it, just a small amount of it, the air sacs in your lungs would bust open and you bleed into your lungs. So you'd end up drowning in your own blood. Okay. I don't want either of those things. I don't want to put something in my mouth that causes my head to explode. And I don't want to breathe something that causes me to drown in my own blood. But if I put those two things together, I make NaCl, which is table salt. So exploding head, drowned in blood, salt my fries. This is the kind of stuff that intrigues me about chemistry. So that's it for this video. Thanks for watching.